Hello everyone, this is Revati working as an assistant professor in the Department of Artificial Intelligence and Data Science. In my previous video, we have seen about Internet Protocol version 4 and how it will be applied in the real world problem solving. In this today's video, we are going to see about IPv4, that means Internet Protocol version 6. Using design thinking approach. Let's see the topics one by one in detailed manner. First, introduction. Empathize real world problem. Imagine every person using smartphones, laptops, smart TVs, watches, and IoT devices. The internet needs a unique address for every devices in order to communicate with each other. Then IPv4 addresses are running out and IPv6 is the solution. Why IPv4 is running out? IPv4 supports only around 4.3 billion addresses, which is not enough today's communication. IPv6 provides a huge address space, but better security and support for modern applications like video streaming and IoT. IPv4 address structure. IPv6 uses 128-bit addresses written in hexadecimal format separated by colons. For example, FDEC colon 74 colon B0FF colon 0 colon FFFF. Then IPv6 also supports address compression to simplify the notation. The next is the think pair share activity. Think about this question. If you were a network engineer in 1990s, would you immediately adopt IPv6 or continue extending IPv4 using NAT and CIDR? Discuss the trade-offs. This is the IPv6 packet format. IPv6 packets contain a fixed 40-byte base header and optional extension headers. Important fields includes version, traffic classes, and flow label, payload length, and hop limit. The next is the quick concept check of IPv6. In this activity, students identify IPv6 addresses expansion and choose suitable IPv6 address types for practical networking scenarios. Then the next is the transition from IPv4 to IPv6. Nowadays, organizations use methods like dual stack tunneling and NAT64 to transition from IPv4 to IPv6 without affecting the existing communication systems. The next is the industry case study. Google successfully employed IPv6 using dual stack technology. Today, a large percentage of Google traffic uses IPv6, improving speed and reducing the NAT overhead. The next is the IPv4 strength and limitations. The IPv6 offers massive address spaces, that means end-to-end connectivity between the client and server, and built-in security also it will provide. However, migration cost and training requirements and compatibility issues will be slowed down, depends on the adoption of the location. The next is the lecture summary of IPv6. Uh, this is the lecture summary. Today we learned why IPv6 was um, introduced in our day-to-day life. IPv6 address structure and address types, packet formats of IPv6, why the IPv6 will be introduced, and the transition methods of IPv6, and the how it will be applied in the real world examples. Then the key takeaway from today's video is IPv6 is not just the future, it is the present requirement for supporting billions of people to connect together without any network traffic uh, in order to efficient and secured manner. Then the next is the some of the references as I referred for today's PPT. I hope this video will gives the clear idea about IPv6 and how the IPv6 will be introduced for overcoming the IPv4 problems. Thank you very much.